Hello team, in this we're going to talk about DevOps. So DevOps is a cultural or organizational approach to software development, where we join the development, the quality assurance, and the operation teams so that they work more closely together. So DevOps is an extension of agile software development methods that relies heavily on automation and orchestration. And as we'll see, is a very good match to developing and deploying applications on the cloud. So here are two examples of what we can get when we join the development, QA, and operation teams. So if the operation teams requires that a serverless application is built because that's what's easiest for them to deploy, they can coordinate with the developers so that they design and build stateless code, which is easier to deploy in a serverless fashion. And if we are building an application using the microservice approach, the operations team can inform developers on what's the preferred container solution, for example, Docker, or if they should use Kubernetes or not, and also how to modularize the microservices and how big each microservice should be. DevOps relies heavily on the concepts we've seen so far in this course, in particular automation and orchestration. So DevOps uses continuous integration to automate building and testing of code, and this speeds up iterations when building applications. Continuous integration gets us version management, which allows us to separate development code from production code. For example, we might have multiple development branches and maybe even multiple production branches, depending on whether we have multiple deployments or not. When using DevOps, we try to build small modules to compartmentalize testing. So instead of having a big monolithic application that's hard to test, for example, if we make some changes to the filters module over here, we might need to test the whole application, which might be costly and take a lot of time. If we build an application using small modules, for example, when using a microservice approach, when we change the filters microservice, we only need to test the filters microservice. And when using DevOps, because we build and deploy code very frequently, we need extensive testing to ensure software quality. So developers make changes to the code, and these changes are automatically tested. So the developers get some confidence that their changes will not break in production. And one approach that takes this to an extreme is test-driven development. So in test-driven development, we write the tests before we write the code. So we specify what the code must do in tests, and then we write the code, and the code is only accepted when it satisfies all of the requirements that I have captured in tests. And DevOps also makes use of continuous delivery to automate software deployment. So continuous integration is about automating building and testing, and continuous delivery is about automating deployment. But before we talk about continuous delivery in DevOps, let's talk about the classic approach to software delivery. In the classic approach, we first package the software, and then we find a low risk or low load time to deploy that software. Sometimes this is called a maintenance window, and we might even warn users about the possibility of unavailability during the upgrade. So to give an example, I maintain a testbed where we operate routers across the globe, and these routers have a lot of configuration built in. So we have a backend that automatically builds configurations for these routers. So this part of our operation is automated and it's okay. But whenever we need to actually push configurations to the routers, this process is manual and it's subject to fail. So when the routers restart with the new configuration, sometimes they don't behave entirely as expected. So we need to go in manually and fix some things. So whenever we need to push configurations to the routers, we pick a low risk time to deploy. For example, we might choose 2 p.m. so that if something goes wrong, we have the rest of the afternoon to debug the problem. And possibly, when we are upgrading the service, we might need to bring the application offline, even if for a short while, so that we can swap versions. So this approach is not a very good fit for cloud environments. First, if our application is large or has a global user base, then there's no low risk or low load time to deploy. The application might be used constantly. And in a microservice architecture, then this is indeed the case, because a microservice is used by other microservices in the application all the time. So you can't bring it down, otherwise you might cause problems for the other microservices, even though they're not being updated. So let's talk about how we can deploy applications more rapidly in DevOps. So first, we've talked about smaller modules and extensive testing improving software quality. So this is one of the things that we use in DevOps, and it's in the CI side of things. So this leads to less errors in production. And the other thing we talked about when discussing orchestration is that we can roll out new releases incrementally. So containers running the old version don't need to be shut down during the upgrade. They can continue running and they can finish servicing ongoing requests. And when the containers running the old version finish servicing their requests, then we can shut them down and no client experiences any downtime. And then, while we're shutting down the containers running the old version, we are bringing up containers running the new version. And we spawn these new containers and monitor them closely for errors. And if errors occur, we can roll back the release. And if no errors occur, then we will eventually migrate all the users to containers running the new version, and we're going to shut down all containers running the old version. So how do we do this? One approach is the sandbox trial approach, where we have the production system is unchanged and it's running on the production infrastructure. And we also have a sandbox infrastructure where we're going to run the upgraded version of the system, and they're completely isolated. So the sandbox deployment has the upgrades, it doesn't impact the production version at all, and we can test that the application behaves as expected in the sandbox. Two problems with the sandbox approach is that it incurs a high cost because you're going to have to build additional infrastructure to run the sandbox, and it may not catch all errors because of this isolation. So the infrastructure may be different. Canary deployment is another approach we can use. So here we have our image processing application from a few videos back. So it has an external API and many microservices. And here we see that microservices are deployed multiple times, say because we have many users and one instance of each microservice is insufficient to serve the load. So we have multiple instances too. Now say that we have developed new functionalities in the filters microservice. In the canary approach, what we're going to do is we're going to deploy a new version of our microservice with the updated filters. So this new microservice will interact with the rest of the system as normal, and we will monitor it closely for errors. So if any errors occur, we will bring this new updated version out and debug it and then try the deployment again. But if no errors occur, we will launch a new instance of the updated filters and then shut down one of the old filters, and eventually we will migrate all the users to the new updated filters. So the main part in the canary deployment is when we start the migration. So we create a new instance of our microservice with the updates, and then we monitor it very closely for errors. And if errors occur, then we roll back. And if errors don't occur, then we continue the migration. Blueprint deployment is a third approach that we can use. And it's very similar to sandbox trials. One difference is that we have a single production infrastructure. And the production infrastructure will run two versions of our applications, the blue version and the green version. One version will be the production version with the old code, and one version will be the testing version with the new code. And then we can send some users to the testing version to check that it's okay. After some time, when we grow confident enough that the testing version is ready for production, then we basically swap the two. So the green version will become the production version, and then we will update the blue version so that it becomes the new test version. And then we keep cycling the blue and the green versions in production and updating the testing version over time. So with this in mind, in our router test bed, what we would like to have is automatic generation of configurations. So this part we do have, so it's okay. But we would also like to have automated pushes to the routers. So for example, we could push configurations to the routers every day at midnight. So if we had this, I wouldn't even need to push any button to manually change the configuration on the routers. The system would automatically push configurations to the routers. But to do this, we would need additional functionality that we don't have today. We would need to have extensive monitoring of the router and the traffic to make sure that the automated push of the configuration doesn't break anything, or if something breaks, that we can automatically roll back whenever errors occur. So we would need this additional infrastructure that we don't have at the moment. And this is orchestration. So our system is kind of one of a kind. So we don't have orchestration as good as we would like at the moment. And this is the main idea behind the DevOps approaches, automating as much as possible so that we take humans out of the loop and make the operations more automated. And then we kind of bring together operations and development. So here in this case, to automate the operation, we would need development of monitoring and rollback. Okay, So DevOps does have some difficult aspects to it. So one is a culture shift. If we have very large enterprises with an established culture, then it might be difficult to change. So we would need to change teams to collaborate more closely or even merge teams. And we would need to realign the incentives and the rewards. We need extensive automation and orchestration, which has initial setup costs. Consider, for example, our router test bed examples. We don't have the orchestration in place yet, so we can't actually do extensive DevOps. And there is some maintenance overhead for this, orchestration infrastructure. If we can offload the automation and the orchestration to the cloud provider, then that makes it much easier to use DevOps. When using DevOps, there's a higher risk from rapid development. In DevOps, we build a lot of tests. We have this orchestration infrastructure to automate rollout and rollbacks, but failures can still occur. And they might occur more often just because you're pushing things more often into production. And finally, we might be more susceptible to system-wide failures instead of module failures. So in DevOps, we build extensive tests and we test each small module thoroughly. But when we deploy in production, we might get global or cascading failures that we didn't catch when testing each module in isolation.